move on to a different topic for the older kids that want to try to start into physics. So we have something generic here. It's called balanced and unbalanced forces, resultant of forces, which is also known as net forces. So this is probably like the best way to understand versus having to see something really scary like this. Okay, it's the same thing. It's the same thing, but it's been broken down to the point where you actually can visually comprehend this. Okay? So we are going to use the table to understand resultant vector and Newton's third law. Now I wrote out what Newton's third law states. It says two bodies interact. When it should be when two bodies interact. That was me being lazy. When two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. So what's magnitude? So magnitude is understood as the force, and I put down force understood in all, net, or sum. That is the best way to understand it, okay? Another way is you can rewrite it as saying it's the sum of all forces. You're going to get a teacher that'll say, be careful with that. Not always true. So we're going to move forward. I'm going to leave that tidbit. We're going to go to the first example. So we have something in the middle that's holding the two forces, demonstrating their direction. So we have 750 newtons heading in the right direction, and we have 500 newtons heading in the left direction. Okay. So technically, if it's heading in the right, it's positive, and if it's heading in the left, it's negative. All right? So if you had to rewrite this as a math equation, it would be 750. Those of you seeing my numbers, I had a student that was dyslexia, so my numbers are dyslexia-proof. 750 newtons minus 500 newtons. Okay? Because we've interpreted the direction, and we said that if it's going in the right, then it's positive. It's going in the left, it's negative. So in all correct math logic, we're going to rewrite it as 750 newtons minus 500 newtons if it was the opposite. So let's say we had something like this, where we had more newtons on the left side than we did on the right side. Then that's when you would write it as negative. So you would rewrite it as a negative number with the Newton measurements plus the other force. Okay? And it is possible. It is possible. Anything's possible in physics. Okay. So looking at this, is it balanced? It is unbalanced. Unbalanced means that we have a greater force pulling the other force. This one is balanced. That means we have two forces pulling in the opposite direction, and they are the same. So that means that the resultant force is going to be 0. 0. So then what's the direction? Is it right or left? Well, from my understanding, 0 is a positive number, so therefore it is to the right. You will get a teacher that says it is neither. But when you get older, you're going to find out in more complicated math classes, 0 is actually a positive number. It can't be a negative. Otherwise, we're going to end up in the worst Star Trek battle scenes, all right, with the ships. All right, so now we're going to go back to the original first example of this one, 750 newtons and 500 newtons. It's unbalanced, and we're going to figure out the math real quickly. It is taking out the zeros. Hang on 1 second. I'm shaking. Is 250 newtons. Okay. Double check your math. Always double check your work. So 500 newtons plus 250. You should always have equal double checked work. 750 newtons. So my answer added to this part of the equation equals to my greater force. Okay, I'm kind of avoiding a lot of extra terms to avoid any type of confusion. Okay, we want to try to do that. You want to try to be able to memorize and solve the problem based on the greater terms in physics, not the smaller descriptive terms. That's where you will make a lot of mistakes. So now it's in the positive direction. Why is it in the positive direction? Because our 750 Newton is greater than the 500 Newton on the left. Okay? So this would be a great example right here. This one actually would be 300 Newtons. Now I write mine different. That's really bad. Mine different because I am left-handed. And it's going to be minus 500 Newtons. Okay. My answer is going to end up being here 200 Newtons negative. Okay, that's the resultant force, and that is what determines it to be in the left direction. So because it's positive, it's going to be in the right direction. And it is still, in this one, an unbalanced force. Okay? Does that make sense? And let's see. And also another lazy. I don't like teaching physics. I feel like I'm always incorrect when I teach it. Now, looking at this one, off of this one, same thing. We have a greater force on the right. Also being lazy again. And we have a smaller force on the left, so we're going to rewrite it as 1,000 newtons minus 500 newtons. It is unbalanced. We have a greater force pulling it in the opposite direction. And our resultant force, which is actually, the resultant force is the same thing as the magnitude, okay? Because why? The resultant force is the sum of all forces. The problem is that you're seeing this as a difference equation, which is true, but it's actually just addition with some decreases in the greater force, okay? Add a little Star Wars into it. Remember, physics is all Star Wars, people. It's all Star Wars. It is. It is. It is. All right, so 1,000 newtons minus 500 newtons gives us 500 newtons. Okay. Now, the greater force is in what direction, the right or the left? It should be the right, therefore, it's the positive and also the negative. So, because it is the greater force in the right direction, my answer is also positive too, so therefore it's going to go in the right direction. So let me clear up that ambiguity that I just said. With this one, where's my greater force at? It's in the left direction. Okay, so it's in the left direction and it's negative. My other force, my lesser force, is in the right direction, so it's also, but it's positive. But because my greater force is in the left direction and it bears the negative, the answer is going to have the negative 200 newtons, and with the direction in it being in the left, 200 newtons and it being in the left. Okay, so down here, my greater force is actually on the right, so it's going to bear positive than my lesser force, which is bearing the negative. So that means that my answer is going to be positive, having 500 newtons, and it's going to be in the right direction. Why? Because that's where the greater force is at, and it happens to have a positive sign on it. All right? Because why? We established that if it's in the right direction, it has a positive. In the left direction, it has a negative. Nervous, yes. If it's going in the down direction, it's still negative, and if it's going in the up direction, it's positive. Okay? Which is what that is all about right there. Okay? So that's the start of balance and unbalance. Let's do this one. Everybody's like, yeah, you forgot one. So we all know this is balance because both sides are equal. It's 500 newtons, 500 newtons. This one's positive, this one's negative because it's in the left. It's negative because it's in the right, it's positive. So if we do the equation, I'm running out of scratch word space. 500 minus 500. I'm being bad again. There we go. That becomes 0 newtons. Okay? 0 newtons in technically the right direction, or no direction because it's in the hold right here. It's being held. There's neither a pull or anything. Okay. But technically there is a direction. You will find that out with a professor that is really struggling with the infinite theory. I'm being facetious there. I'm being funny. But yes, it is in the right direction or no direction. Okay. Just depends on how you interpret 0.